Hi everybody, today we're going to talk about Newton's law of cooling because it is very applicable in many pre-calculus exponential function situations. So first of all, Newton's law of cooling states that the change of temperature is proportional to the temperature difference. So as you can see here, we have a graph of the cooling of water. You can see the time on the x-axis and the temperature on the y-axis. And here we have the formula for Newton's law of cooling. We're going to go through and make sure we understand what each of these represents. So our first symbol is the temperature at time t. And that basically means whatever time. T1 is going to be the temperature of the surrounding environment. T0 is going to be the initial temperature of the object. And negative K, or K, is going to be our constant. This will be different for each object. And T, obviously, is going to represent whatever time. So next we have an application problem. Cole is in a tea shop, and she orders a cup of tea with a temperature of 200 degrees. She's going to walk outside the tea shop, and it's 70-degree weather. After 10 minutes outside, the temperature of the tea is 150 degrees. So we are supposed to find a function that models the temperature and the coffee at time t. So we know that our x is going to be the time, and our y is going to be the temperature. So we do have an ordered pair for that. We have 10 minutes and 150 degrees. So we are going to use that information to model a function. We know that the initial temperature is 70, so we're going to plug that in there. Then we need to subtract the 200 and the 70 to get 130 here. Then we of course have our E, we're solving for the K, and we are going to plug in our ordered pair for the T and then for the temperature. So we'll have 150 degrees equals 70 degrees plus 130 degrees e to the negative k times 10. And we can subtract the 70. That's going to give us 80 equals 130 e to the negative k times 10. And then we will divide by 130, which is going to give us 8/13 equals e to the negative 10 times k. And since we have an e here, we are going to take the natural log of both sides so we can get rid of that. This is what we end up with, and once we solve this using a calculator, we will get k equals negative 0.0486. And so now that we have solved for our constant, we are going to plug that back into our equation. And that is going to give us as follows. And this is going to be helpful when solving the rest of this problem. For the next part of this problem, we are going to be finding the temperature of the coffee after 15 minutes. So that means our t up here is going to be 15. And we are going to plug that in. The easiest way to solve it from here would be to plug this in on your calculator since we have all the information, and that is going to give you an approximate temperature of 132.71 degrees. For the next part of the problem, we are going to be solving for the time when the coffee will have cooled to 100 degrees. So we are going to plug in a 100 over here, and we are going to be solving for our t. First step is going to be to subtract 70 onto both sides, and then we are going to divide by 130. That is going to give us 3 over 13 equals e to the negative 0.0486 t. Then to undo this e, we're going to take the natural log, so we are going to get t equals ln 3/13 divided by our constant, and that is going to give us approximately 30.17 minutes, which equates to 30 minutes and 10 seconds.